Is JC vectors really the hardest JC1 topic? Over here I have a very standard question from VJC that I thought every single J1 student need to know how to solve. And the context of the question is very simple, right? We are given a line over here, and let's just call it L. And we have point A that lies on L, which is A over here, right? And it's given as 8, 0, -1. Now we have another point B over here, which doesn't lie on the line, and it has a direction vector of 1, 3, 1. And we are asked to find the closest point F, which is essentially the foot of perpendicular, right? So the foot of perpendicular of any point will be the closest point to B. And we're asked to find the position vector of this. So how can we actually tackle this question in the least number of steps? This is exactly what I teach my students at my Math Tuition Center, A1 Math Academy. So the way we do this is, first and foremost, let's find the vector equation of the line. So for line L, right, we know that the equation of the line is x minus 8 over 6 equals to y over -1 equals to z plus 1 over -4. And now we have to assign a parametric. So I'm just going to assign this a parametric, whereby the parametric can take on any real values. And then here we have x minus 8 over 6 equals to parametric, y over 91 equals to parametric, z plus 1 over 94 equals to the parametric. And then from here, I will solve. So x equals to 8 plus 6 of the parametric, y equals to negative of the parametric, z equals to -1 minus 4 of the parametric. And therefore, the line L can be written as R equals to 8, 0, -1 plus the parametric of 6 minus 1 minus 4, right, where the parametric is a real value. So after we do this, note that F is indeed a point that lies on the line, right? It is a point that lies on the line. So I can say that since F lies on L, right, OF would be 8, 0, -1 plus the parametric of 6 minus 1 minus 4 for some unique value of the parametric, right? If I am able to find out what the unique value of this parametric is and sub it back into the equation, I will essentially find OF. So therefore, OF can be said to be 8 plus 6 of the parametric, negative parametric, -1 minus 4 of the parametric for some unique value of this parametric. And therefore, we are able to find BF in this case over here, right? BF would just be OF minus OB. And that would mean I would take my initial vector over here, which is 8 plus 6 of the parametric, minus parametric, -1 minus 4 parametric, minus OB, which is given as 1, 3, 1, right? And therefore, I'll end up with 7 plus 6 of the parametric, -3 minus parametric, and -2 minus 4 of the parametric. Now, why do we want to find BF? Very simple. It's because BF, we can see, is perpendicular to the line, and therefore the dot product between this and the direction vector of the line, which we can tell is as this, which is 6, -1, -4, will be 0. So over here, I just need to write a simple statement, which is since BF is perpendicular to the line, right, we know that 7 plus 6 of the parametric, -3 minus parametric, -2 minus 4 parametric, dot 6, -1, -4 equals to 0. And when we actually solve this, so 7 plus 6 parametric, and then minus -3 minus parametric, plus 4 plus -4, -2 minus 4 parametric equals to 0, we will solve that the parametric actually equals to -1. So once we know the parametric equals to -1, we can then sub this back inside my line over here to find the specific value of OF. Therefore, OF would just be 8 plus 6 times -1, negative times -1, and -1 times or -4 times -1, right? And therefore, my final answer to this would just be 213, which is the final answer to this question over here. So to J1 students, your thought process in vectors is very, very important, because you need to know sequentially what needs to happen in order for you to derive the value needed for the next step. And vectors is one of those topics that's very, very hard at the start, but with more practice, you will get it. And if you're still struggling with H2 Math and you want to start off the year in the correct foot, WhatsApp the number on the screen over here for my J1 classes at my Math Tuition Center, A1 Math Academy, where I'm currently opening a lot more J1 timings to take in a lot more students with a maximum class sizes of 4 to 8, so that I'm able to keep the group sizes small and teach you in a way that you can actually understand. So for more information, WhatsApp the number on the screen and I'll send you the info there.